In this video, we're going to talk about multiplying and dividing rational expressions. Before I do that, let's just remind ourselves that we know that rational numbers are anything that can be written as a fraction. And we know that to multiply fractions, we can, if we like, simplify first, reduce first. That is, before we multiply, we could say 2 goes into 2 once, 2 goes into 4 twice. Then we could multiply the numerators, 3 times 1, and the denominators, 2 times 5, and there's our answer in simplified form. The same idea holds with rational expressions. We're going to think of a rational expression as being like a fraction, but we will allow any polynomial in the numerator and denominator. And we are in particular going to talk about how to multiply those today. So as an example, let's take something like, say, 5 over x minus 1, and we'll multiply that by x minus 1 over 25 times x minus 2. Now you may notice that this one has very conveniently been put into factored form already. Very shortly, you're going to have to do the factoring, and that's usually what the hardest part of this is. Now we can cancel factors, like factors. So we cannot cancel that x with that x, because with the minus and plus signs in there, they can't cancel independently. So instead, we can say this factor of x minus 1 cancels that one and leaves 1, because x minus 1 goes into x minus 1 once. We can say 5 goes into 5 once and into 25 5 times. Then we can multiply the numerators, 1 times 1, and in the denominator we'll get 5 times x minus 2. I would recommend that you just stop here. There's really no advantage to multiplying that out, although you certainly could. It would not be wrong to call that 1 over 5x minus 10. But it's more work and it doesn't really serve any purpose. Now, we want to talk about a special cancellation, because this will come up fairly regularly. And I'm going to show you why it works the way it does once, but then after that, you don't have to go through all these steps. So suppose we started with, like, say, x minus 2 over 2 minus x. Now, those are not identical, so we can't really just cancel it and leave 1, but we're going to kind of think our way through it here, and I'm going to show you why it works the way it does. If we factor a negative 1 out of the numerator, that would leave a negative x and a plus 2 behind, and I'm going to just leave the denominator as it is. Then I can rearrange that subtraction, or that addition rather, and call that 2 plus a negative x. And then if you want the 2 plus negative x, you could write as just 2 minus x. And so what we've done is we've taken this original x minus 2 over 2 minus x, and we've maneuvered it so that it cancels and leaves negative 1. So we'll just know that's the way that works for these kind of situations where we have two subtractions, but in reverse order. We'll just cancel them and leave negative 1. Let me give you an example. So let's say we have x plus 3 over x cubed times 3 minus x times x minus 3 over 5. So here is the situation that we talked about, where we have a factor in the numerator and a factor in the denominator that both have these subtractions, but they're reverse order. We are just going to agree to cancel them, but leave a negative 1. Now, in this case, we can also cancel this x with one of those x's, and that's as much as we can do. So if I can get my pen to cooperate, we're going to get just that negative 1 times the x plus 3 in the numerator, and our denominator will be a 5x squared. And you can leave it like that, or if you want, you could distribute the negative sign. There's no advantage of one over the other here. Okay, so let's look at something where we're going to have to do more of the factoring. So let's consider, let's do x over x minus 1, and we're going to say divided by, and we'll call this x squared over 1 minus x squared. Now, it may be tempting to just start canceling away here, but you cannot cancel those x squared as it is there, because that's not the way that, that multiplication works. You couldn't say, that 3/5, which can't be reduced, you could not say, oh, let's see, I want to think of that as 2 plus 1 and 2 plus 3, and cancel those and call it 1/3. And that's what you're trying to do if you're canceling the x squareds here. So that doesn't work. Instead, what we're going to do is, now we also have to deal with this division, and we know that division is multiplication by the reciprocal. So I'm going to flip what follows the division symbol, and then before I get carried away and try to cancel, I'm going to factor that 1 minus x squared as the difference of two squares. So that's going to be a 1 minus x and a 1 plus x. Now we can see again, here's our situation of the x minus 1 and 1 minus x are going to cancel and leave a negative 1. We can also cancel this x with one of those x's, and we're left with a negative times the 1 plus x over the x, which you're welcome to leave just like that, or you could also, if you want, distribute the negative sign. You cannot cancel those x's. That is not true. Now let's look at one that's more typical, where we're going to have to do a whole bunch of factoring. So let's do x squared minus x minus 6 all over x squared plus 6x plus 9, and we're going to divide that by x squared minus 4 all over x plus 3. So we have the division, so we're going to multiply by the reciprocal, but as we rewrite this, I'm going to factor each of those. So using your box and diamond strategy, or whatever it is that you use, this is going to factor into x minus 3, x plus 2, and the denominator is going to factor into x plus 3 times x plus 3. I'm going to multiply by the reciprocal, so that's going to move that x plus 3 into the numerator. And I'm going to factor the x squared minus 4 as the difference of two squares. Now the hard work is done, all the factoring, that's the tough part. Now I think the fun part is we get to cancel something, I hope. So this x plus 2 will cancel with that x plus 2. This x plus 3, let me change colors there. That x plus 3 will cancel one of those x plus 3's. And so at the end, we're going to get an x minus 3 left in the numerator, and an x plus 3, and an x minus 2 in the denominator. And I would not recommend distributing all that stuff in the denominator. Now I'm going to go to a new page, and we're going to talk about some special factoring here. So we are going to need to know how to factor the sum and difference of cubes. So the sum of cubes is anything that has two perfect cubes that are being added together. And it turns out these factor into a plus b times a squared minus ab plus b squared. So things to notice, because these are going to be dangerously similar but yet different than the difference of two cubes. It's a binomial and a trinomial. The binomial term is the same sign as the original that we're factoring. The trinomial looks like it might be a minus b quantity squared, but that is not true, because that is not a minus 2ab, which we would get in that case. Things to notice is the signs alternate. You go plus minus plus. The powers of a go down, a squared, a to the first, no a. The powers of b go up, no b, b to the first, b to the second. Now let's just convince ourselves this really is the right factorization. So I'm going to distribute that and try to see if we don't get a cubed plus b cubed. So a times a squared is a cubed. A times negative ab is a negative a squared b. And a times b squared is a plus ab squared. Now I'm going to come back with the b, and the b times a squared is an a squared b. The b times negative ab is a negative ab squared, and the b times the b squared is a plus b cubed. So when you add those, you can see that these terms cancel each other out. That's sometimes called telescoping when it does that. Kind of collapses like a telescope. And we do, in fact, get exactly what we claimed we would. It is going to be the right factorization. Now, the difference of two cubes is similar, but just enough different that it's easy to get confused. So a cubed minus b cubed is again going to be a binomial times a trinomial. The binomial again matches the sign of the original. The trinomial is going to go down in powers of a and up in powers of b, but in this case, everything is positive. They're all being added, different than the original, or different than the sum of cubes. So notice each of these factorizations has one negative sign in it. In the sum of two cubes, the only term that gets a minus sign is the middle term in the trinomial, and in the difference of two cubes, it only appears in the binomial term. Let's see how we might use this. So if we take something like x to the third plus, let's go minus 8, x to the third minus 8 over 2x to the third, and we will multiply that by 4x over x squared minus 5x plus 6. So what we're going to do is, here is our difference of two cubes. So we're thinking of that as a to the third minus b to the third, like we just talked about. The role of a will be played by x, and the role of b will be played by 2. So our a minus b is going to be an x minus 2. Then we're going to get an a squared, which for us is x squared. We'll get a plus ab, which for us will be a plus 2x, then a plus b squared, which will be a plus 4. And the denominator stays as it is. And I'm going to factor that denominator in the second term. So from your box and diamond or guess and check or however you do this, that's going to factor into x minus 2, x minus 3. So we can cancel the x minus 2s. Anything in the top can cancel with anything in the bottom. The 2 goes into 2 once, into the 4x twice. And this x will cancel one of those x's. So at the end of the day, we are going to get that 2, and then the x squared plus 2x plus 4 over, and then we're going to have an x squared and an x minus 3. Okay? We'll do a different kind of example. It sometimes throws people. I'm going to have x's and y's mixed in together, but we can still do our same strategy, so don't get thrown off just because there's y's that are also appearing here. So I'm going to do divided by here, x squared plus 3xy and plus 2y squared all over x. So we can still proceed in factoring using our box and diamond, and if you do the guess and check, it works there as well. Your first terms are going to be the x's. Your second terms are going to have y's in them. So you can see that when we take 2y times negative y, that is going to give us the 2, well, that's supposed to be a squared. Let me go back and fix that. I don't know if it won't, oh, it does let me do that. That's supposed to be a squared. I just wrote that down wrong. Sorry about that. Hard to get the right answer when you start with the wrong problem. Okay, in the denominator, We can factor out a greatest common of x squared, and that's going to leave behind an x plus y. I'm going to multiply by the reciprocal. And now we're going to do our factoring skills, our box and diamond, or guess and check, however you do it, with the denominator as well. And so we should get an x plus y and an x plus 2y. So there's our factorization. The fun part is we get to cancel the x plus 2y's. We can cancel this x with one of those x's, and we end up with x minus y over x times x plus y squared. Let's talk about how to do what's called a complex fraction. So I'm going to do a problem where we have x squared over x plus 1, x squared over x plus 1 to the second over x plus 1 to the third. So that is appropriately enough called a complex fraction. This we just read as a division symbol, so it's really just a division problem. So we're going to take the x squared over x plus 1 squared. I'm going to multiply by the reciprocal, which is going to put that x plus y to the third up in the numerator. And now we can try to cancel. So these two x plus 1's will cancel two of those three x plus 1's. This x will cancel one of those x's. And so what we're going to have is that surviving x and the surviving x plus 1, and that's it. So you're welcome just to call it that, or if you like, you can distribute it. Either way is equally acceptable. So hopefully this will give you some success on that the multiply and divide rational functions worksheet.